Swayam Prabha. Digital India. Educated India.
Welcome back, dear learners, to this NPTEL course on low cost building materials and techniques. My name is Dr. Vishal Chettry and I am working as an assistant professor in the Department of Architecture, Planning and Design at IIT BHU Varanasi. So, I have been associated with this department since 2023, and I have been taking this course over here as an elective, and this is the first time that I have tried to float it as an NPTEL course. So, we have covered till this particular lecture, we have covered details about using low cost architecture or low cost building materials and techniques in different contexts. So, we have studied basically what local or especially the earth based construction is all about, and how low cost material can help in minimizing the overall budget of a construction, and understood its wider applications in the society, how it can fulfill the demand for housing that is there in the society till now. And the government of India also envisions that at least by 2047, that is the time when India will be will have at least covered 100 years of independence. So, by that time at least everyone should have a building, or everyone should be having a residence of its own. So, as also that there are large populations or large section of society who still can't afford the cost of construction. So, that is the reason why they are still homeless and they are living in informal settlements and other places where it creates lot of problems and lot of issues for their quality of life. So, with that intent, this course is being designed so that anyone who may be student or who may be any professional, if they see or if they get to understand different materials or different way of designing low cost buildings or low cost buildings with the different low cost materials and techniques, probably it will help somewhere in promoting sustainable development. Also, it will help in providing low cost solution for the people who are still homeless and who do not have such a good quality of life. So, with that intent, this course is designed, and let us now today focus on understanding about some of the contemporary innovations and the sustainability aspect for the low cost, or for especially for the earth based construction. The content of the presentation here includes the details about the innovations in earth construction, because there are very popular earth based construction which have covered in detail in a glimpse of different types of earth based construction were shown in the previous lecture. But now let us also see some of the recent innovations that has happened in the earth construction, and in later units will cover them in detail, but just to give you a glimpse of what are these innovations, so we will cover this in the this particular slide or in the presentation. The mechanization in earth construction is also covered in this presentation. It will help us in understanding these innovations in detail. Then also will understand the structural advancements that has been happening in earthen buildings. Along with that, the sustainability aspect of earth based construction. Then we will understand the energy and carbon performance of earth construction. So, how is it helping in promoting sustainability, because till everyone talks about that earth based construction is a very sustainable, is a very very much useful to promote sustainable development. but let us understand in terms of statistics that how these are adding in promoting energy and carbon performance of the structure or of the entire project. So let us understand this in this particular presentation. Then we will focus on some case studies which have utilized earth based material for construction. With this we will conclude the lecture, and then some wrap up activities, topics which are covered in the next presentation along with resources will be shared with you. Before we proceed further, let us understand what we have covered in the previous presentation, so that you will be able to connect this with the upcoming presentation. So in the last presentation we had understood that stabilization as a process, how it is useful in improving overall quality of soils by adding some stabilizers in the soil. So it basically overcomes the limitation of raw mud such as low strength and high water sensitivity that is present in the earth. So to limit that or to increase the strength and durability of the earth based construction, stabilizers are added. So this is what we had understood, and also we learned that the need and objectives of stabilizations, why is it done, and then also it helps in including increasing the strength, reducing water absorption, as well as controlling the shrinkage that happens in earth based construction. We also explored different types of stabilizers, cementers, chemical or the hybrid ones. We also examined how stabilization works through mechanisms like cementers bonding, pozzolanic reactions, or if it is through fiber reinforcement. We also identified some key selection criteria based on based on certain factors like soil type, climate, strength requirement, cost, construction technique, as well as the environmental impact of some of the stabilizers. Based on that, the stabilizers for the project or for the earth based construction can be utilized. We also analyzed some advantages such as improved strength, durability, reduced maintenance and cost effectiveness of earth based construction, along with some limitations that are present in earth based construction if we use some stabilizers which are of higher carbon footprint and need for skilled labor. So at this moment let me know that which is the higher carbon footprint stabilizers that are added in the earth based construction. So just note your answer and post it in the discussion forum, so that we may have a quick understanding about whether you are able to grasp the topics that are covered in the presentation. So coming to the topic that we will be covering in this presentation, which is basically on understanding innovations in earth based construction. So traditionally earth based construction relies on manual techniques like cob wall or adobe blocks or rammed earth. So these are all manual techniques where where you require with the help of your hands or even the feet to mix or to create some kind of earth mixture, then possibly to bring that mud from the place where it is mixed. For example, if I am mixing some mud in a particular table or in a particular area in the ground, then from there it has to be brought to the place where it has to be used. So it is completely a manual process in case of adobe block. So what we do in adobe block is that we create a earth mixture before after doing test and all, or after adding stabilizers, we create a mix and then that is added in the mold, and then it is earth is that after it takes the desired shape, we take out from the mold and we keep it for drying, not directly under the sun but under the shade. So this is the entirely, as I explained you the process, it is completely a manual process. So similarly in case of cob wall, what we do is we do not, the difference here is just the like we construct a wall without the use of any mold or any form work. So whatever the mix that we have created, so that has to be taken and then it has to be or we can create some form by our own hand. So either in the shape of egg or in shape of an oval kind of shape, spherical shape. So we have to create that and then we have to bring it on the place where we have to erect the wall. So there we have to put it forcibly so that it gains the desired strength and it bonds well with the with the plinth or either with the adjoining any other component. So that is there. So it has to be put through a lot of strength, and once it is poured over there, so we have to lay layer by layer process. So once the ground layer is over, then the top layer is started. So this is how the process of constructing cob wall happens. Then in case of rammed earth wall, using locally available materials with minimal processing is basically done in case of traditional earth based construction techniques. But these techniques or these methods were highly climate responsive and culturally rooted. So for example, if you are drying adobe blocks or cob wall, so we can't do it somewhere in the rainy season or during rainfall. So it has to be done only in the days where there is no rainfall or there is some decent sunlight that is available. So also it is done in culturally relevant context. So you can't go and design some rammed earth wall somewhere in the middle, somewhere in the area where basically it is in the middle of the city. You can do it, but the availability of labor who knows, or availability of craftsmen or artisans who know how to construct a rammed earth wall, you may not get that in the city easily. So there has been certain advancement in the field where certain techniques which are of less heard of or which are very alien to a certain place can be done very easily with some new innovations or new advancement in this field. So these are now slowly changing, and we can't say here today that something like rammed earth wall we have never heard of, so we can't build it. So that cannot be the answer. So if your client insists that the client desires to build to have a building which is made up of rammed earth wall, so you have to do it, and then possibly do some innovations or use some machineries which will help you in designing or constructing such wall in a place where it is less heard of. So these are some innovations, and that can be done at your level itself, or you can refer to some of the topics that are covered here in the presentation. So in recent decades, so these are the technology shift that has happened, and including the development of compressed earth block, stabilized earth blocks, and engineered rammed earth wall. So these are certain advancement that has happened, and we should learn this because we are right now at a pace where technology has become a prominent tool in every field. So let us also try to use that and try to promote sustainability through our interventions. So modern innovations like scientific soil testing, optimized mix design, and the use of stabilizers, that is somewhere between 5 to 10%, improves the strength of the construction. That is also it enhances the durability of the construction. So mechanization, that is the use of hydraulic press or compactors, has increased the construction speed by 30 to 50% and ensured uniform quality and standardization. So when the project is huge, so it is not just a small residential building of 1 or 2 rooms, so over there you can minimize the use of mechanization process. But if it is a huge project, then to speed up the construction and to fasten the process of construction, you have to use some machines. Probably there may be some carbon emission happening over there, but there are alternatives for energy generation, and possibly you can use that, and machines like hydraulic press or compactors can be used in the site. So earth construction is now being applied in urban housing, institutional buildings, and commercial projects, not just in the rural areas. That we often have a biasness that earth based construction is mostly rural, and it is not it should not, or it may not be seen in a city area. But now there has been change in the way we see earth based construction. So it has been prominently in use in city and urban areas also because of its relevance with the sustainability of the project. Growing concerns about climate change and high carbon emission from conventional materials. So these are two important factors why people are now looking for alternative building materials, and especially they are looking towards earth based construction. So if you do some research, or if you have a proper understanding, especially to the budding architects or the engineers who will be going into the field, if they have this knowledge, possibly they can also contribute in this field, and they can be someone whom one can refer for earth based construction. So you have to now develop skill set along with learning of high tech architecture, or steel and other usage of material for construction. Along with that, you have to also understand the use of such low cost materials and techniques, which is one of the prominent methods for increasing the sustainability or promoting sustainable development here at a global scale. So this is the reason why clients have started become conscious, and they really want something that because we have seen that how much of destruction we have done to our environment and to our pristine nature by using such materials for construction. So if you see the place, just try to Google out places where mining is done for excavating coal, which is not a direct material we use for construction, but somewhere we use electricity for our for the construction purpose. Also the material like the use of steel, so that also requires coal in enormous quantity, and so we are somewhere indirectly contributing a lot towards the climate change and towards the global warming. So we should now be very cautious in using such materials, and then see and look for some conventional materials wherever possible. So I don't say that you have to use it earth based construction at every building or in every project which you handle or which you will be designing. So in case of high rise building, it may not be possible at all to use this, but in certain small scale projects, or at least some buildings where it is possible, you should promote the use of earth based construction or any other locally available material. So also the shift represents a transition from vernacular practice, that is the earlier these materials, the use of earth based, bamboo and other conventional common material, locally available material like stones, were all considered to be more vernacular practice in nature, but now it is converting into something which is engineered and sustainable material, integrating traditional knowledge that is used for construction with the modern science. So this is a new field at all that is emerging gradually in the construction sector. So if you try to understand this in detail, or if you figure out or if you do research on this, or if you pursue your higher studies in this domain, possibly you may be contributing, or you may be some pioneer who would be promoting such materials in construction sector. So so these are some basic background which is related to the innovation in earth based construction. So as I was talking about mechanization that was happening in earth construction, let us understand these concepts in detail. So machine products like compressed earth block. So just to give you a glimpse, we will be covering this in detail in the upcoming presentation, but to give you a brief idea of what compressed earth block is all about, it is something what the adobe block, as I have explained you how adobe block is produced, is manufactured. So in the same process, since this adobe block has some air bubbles, or have some the porosity or the density of the earth per unit is very less, so there is much of air gap that is present. So the strength of that is comparatively lesser than compressed earth block, because what is done here is the earth is actually put in a machine, and then it is pressed. And once the pressing is done or the compression is done, so it is further the bonding between the two molecule over there of the mud or clay becomes more tighter over there, and the more densely packed is the material, the higher is the strength or durability of that earth mixture. So this is the advantage that machine products like CEB brings, and they are now used in many of the modern construction. So so you can just Google out some of the key projects that where compressed earth blocks are used, and you can put it in a discussion forum. We'll have a discussion on the same. Then the next is about mechanized production can increase output to 500 to 1000 blocks per day. So in a project where where it is a huge large scale project like any institutional or any commercial or any some kind of huge site scale project, so there you may require these large number of blocks per day. So there mechanized production is necessary compared to the manual process where only 100 to 200 blocks can be achieved. So if you increase the labor over there, then obviously you are increasing the cost of the project just to fulfill that. Okay, 500 to 1000 can also be produced by manual process by not using mechanized production. So why we should go for mechanized production? But then you are increasing the budget of the project unnecessarily. Then also the use of pneumatic or hydraulic rammers improves compaction in rammed earth wall. So what is rammed earth wall? Is basically formwork in both the sides. So for example, if I have to give you an example of rammed earth wall, so this is something like this, where a formwork is laid in two parts in both the sides, and then it is covered at this end as well as at this end, and earth is actually poured. And then if you just pour the earth in this gap that is created with the two formwork, then it has to be compacted also. So to compact that earth that is poured in this formwork, we can use pneumatic or hydraulic rammers so that the process is quick, and then it is uniform stabilization that may happen in the rammed earth wall construction. Then next, why we need mechanization is because it reduces the construction time by 30 to 50%. So this also is an advantage by mechanizing the process. Also it enables standardization and scalability of the project, making earth construction viable for large scale projects. It reduces labor intensity while still generating local employment opportunities, because we need someone who will be working on the machines. So it is not that we are completely omitting the use of artisans or craftsmen or labor for the project. Why I called these people who are involved in the construction as artisans and craftsmen, which are generally used in other form of arts or in other industries, because these are earth based construction. Somewhere it's not some kind of mechanized process completely. It's a type of construction where we involve humans a lot, and during this process the care that is needed is something at a different level altogether. It has to be done very carefully. So that is why the people who are involved here do it very passionately, and they are the master of this particular art of creating earth based architecture. So that is the reason why I often address them as craftsmen or as artisans. Then also this mechanization, what it does is it betters the construction methods. It focuses the shifts like from structural performance and safety, like it focuses shift to structural performance and the safety of the construction. Overall it improves efficiency, reliability and consistency in the earth based construction. Next, let us look into the structural advancement in the earth based building. So recent innovations have significantly enhanced the structural performance and durability as well as the safety of earthen building. So it has increased the strength with stabilized blocks, where using stabilized earth blocks increases the compressive strength, and then it becomes more durable, and also the strength is increased. So integration with reinforced concrete frames allows multi-story construction up to 3 to 4 stories. So if your entire frame of the structure is of RCC, if it is a multi-storied building, so there possibly for partition wall or for for your exterior walls you can go for such kind of earth based construction. Then enhanced earthquake resistance, addition of horizontal and vertical reinforcement improves the earthquake resistance of the construction. Higher density and durability. Engineered rammed earth walls achieve higher density and durability. It also improves the structural stability using ring beams, plinth beams and lintels, enhances the structural stability of the construction. Overall, the safety, reliability and the optimized design is possible with the use of such advancement in the earth based construction. So let us also look into some sustainability aspect of earth construction. So local availability and reduced transport energy is one of the factor that is considered in earth based construction. So earth is usually sourced on site or within few kilometers from the place where the construction is happening. So the transportation cost is substantially reduced, so by at least 50 to 80% compared to materials like cement or steel. So this is directly impacting SDG 11, that is sustainable cities and communities, by promoting local and resilient construction system. So this is the advantage of and also we can directly relate our actions with SDG goals, thereby firmly saying that earth based construction has power or is somewhere aligned to SDG goals. Circular economy and material reusability. So earthen materials are fully recyclable and biodegradable. Demolished material can be reused or returned to soil without pollution. That is, it goes back to earth without creating pollution. So you can say that even the burnt bricks are made up of earth and there is no cement or but the difference here is it is burnt. So once any earth or any earth based construction, it is burnt, so to disintegrate and go back to earth, it requires like huge large number of years or long number of like many years to actually go back to earth. So that is actually not possible, in case of like the duration is very minimal in case of earth based construction. So circular economy that we often talk about in construction, that is very much possible in case of earth based construction. So earthen materials are fully recyclable, they are biodegradable. So the demolished material, if at all, if it is there in any construction, it can be returned back to earth very easily. It can return back to earth very easily. So it actually promotes SDG 12, that is responsible consumption and production. So this supports a closed loop material cycle and reducing landfill site and resource extraction. Further, there is minimal construction waste that is generated, unlike concrete and fired bricks where earthen construction generates negligible waste compared to these, and leftover material can again be reused, or it can be it can go back to earth very easily without creating much of environmental destruction. Then also it reduces environmental burden and promotes efficient resource utilization, that is SDG 12. Next is related to sustainability aspect is local employment and skill development. So earth construction is labor intensive, creating jobs for local communities and artisans, enhances traditional knowledge system and skill development, especially in rural areas. So it contributes to SDG 8, that is decent work and economic growth, and also SDG 1, that is no poverty. So you are bringing back those people who had these skills in the past but are now jobless because people are moving towards such contemporary materials. So if we bring them back again in construction, in bringing them back again while designing these buildings, we are attempting to promote SDG 11, SDG 1 as well as SDG 8. Next is reduced dependency on high energy materials or high embodied energy materials. Substituting cement and steel with earth can reduce the embodied energy by 40 to 70% in our projects, in our construction projects. Cement production alone contributes to at least minimizing global carbon dioxide emissions, and it supports SDG 13, that is climate action. Next is thermal comfort and energy efficiency. So high thermal mass of earth reduces indoor temperature fluctuations, lowering need for conditioning, air conditioning. It also reduces building energy consumption, thereby contributing to SDG 7, that is affordable and clean energy. Next is health and indoor environmental quality. So earth regulates indoor humidity by at least 40 to 60%, and it is free from toxic emissions that if we use some kind of paints and other finish that we apply on the surface, it emits some kind of it actually deteriorates the air quality of the place, or some kind of smell is produced out of because of the use of these materials, and it affects the health of the user. So in all, the attempt if we use such earth based construction, so health and indoor environmental quality is promoted, thereby we support SDG 3, that is good health and well-being of the user. So in all, these were some of those were some of the SDG goals which can be directly linked with earth based construction. So next is energy and carbon performance. So low embodied energy is promoted through earth based construction, reduced carbon emission, passive cooling performance, thermal comfort that is possible, local material advantage, low carbon building material, and real world validation that is proven through case studies and build projects that we will be covering in the coming slides, that how these use of this material has really impacted the sustainability. So some of the projects which I was mentioning, that how it actually impacts the sustainability of the project. So one among them that we will discuss it today is the Hunarshala Foundation campus in Gujarat. So this project is actually built as a post disaster reconstruction. So after 2001 Bhuj earthquake, wherein the magnitude of the earthquake was somewhere 7.7, so it was a massive earthquake that jolted the entire Bhuj, and lot of destruction had happened. So large scale destruction happened in the entire Kutch region. So there was a requirement of safe, affordable and locally adaptable housing. So Hunarshala Foundation emerged as a key organization working on owner driven reconstruction in that particular region. So they have used stabilized earth based technologies. The foundation promoted the use of stabilized mud block, rammed earth wall, as well as traditional bhunga houses that were built in that region. So stabilization was done of the earth that was available, and then the durability of the earth block was increased. Bhunga typology for seismic activity, the circular form of Bhunga house that was present in that region, which is a vernacular style, has actually it actually distributes the entire shape is preferred so that it distributes the seismic forces evenly, and that is the reason why I keep on saying again and again that vernacular architecture style has answer to all the modern problems that we face when we reside in the building which is made up of contemporary material. So similarly here the region as is an earthquake prone zone, so probably the shape of the building, why our ancestors who resided in that region preferred circular houses, because of this region. So thick earthen walls and low height provided high lateral stability, thereby reducing the collapse risk of the building during earthquake. So these are the reasons why a particular typology or architectural style is very famous in a region. Climate responsive hot arid region that is present in that Kutch area. So Kutch experiences extreme temperature, some in majority it exceeds 45 degrees Celsius during summers. So earthen walls provide thermal mass, thereby keeping interiors more cool, and small openings and thatched roofs provide enhanced comfort in that region. So community participation and skill development is also improved. A major innovation was involving local community in design and construction. So this approach helped in reducing 20 to 30% of the cost and ensured cultural acceptance, that is people adapt to these kind of houses, like they were not scared anymore in living in a building, because earlier the level of destruction and the amount of loss of life that has occurred due to this natural disaster in that region, they were quite afraid in living in such contemporary houses. So possibly with this intervention, that fear of living in similar building, what if tomorrow some similar type of disaster happens, and then the people who will be living may be affected due to that. So that fear was actually eliminated by using this kind of construction technique. So overall it improved in resilience and also enhanced the sustainability outcome of the project. So next is Kaza Eco Community Center in Spiti Valley. So the context of this region is that it is a very cold desert climatic region. So located in Spiti Valley near Kaza, where temperature drops to minus 20 degrees Celsius in winter, and the region lives in a high seismic zone. So zone 4 or 5 is a region where it's mostly located. So there is a need of hybrid construction system. So combined rammed earth wall and compressed stabilized mud blocks are used for construction. So walls have high density and thickness of around 400 to 600 mm is preferred, so that there is a proper insulation and the strength of the wall that can be achieved. Thermal performance: the building maintains indoor temperature significantly higher than outside, often to somewhere 10 to 15 degrees Celsius warmer without mechanical heating. It also demonstrates the effective use of thermal mass and also enhances the solar heat gain. In terms of adapting to extreme condition, it shows that earth construction is not only limited to hot climates as we have seen before, it is very much usable in cold desert environment also. So using local materials, it reduces the transportation challenges in remote areas. So that is the reason why constructing building in remote areas or hilly areas is very costly. So you will not find people using lot of steel and RCC, but these days people are using it assuming that it is to it will withstand the test of time and all, but environmentally as well as in terms of the entire region, the material, the conventional material is not something which is sustainable in nature. Also in terms of passive solar heating, Trom wall system can be adopted. So you can explore more on what Trom wall is. It is something which is a very thick wall which is constructed, and some kind of material glass chamber is created outside the wall so that it absorbs much of sunlight, and then it radiates, it absorbs solar radiation during the day, and then it releases heat during the night because of some openings that are kept at the lower level and at the upper level. So these are some techniques by which passive solar heating in this region can be promoted using such technologies. Also, it is an earthquake resistant design. It includes reinforcement beam bands in between, like plinth, lintel and at roof level. Sustainability and replicability is very much higher in this kind of project. So next is modern rammed earth house, which is taken from Airbay in Spain. So advanced earth construction techniques like which showcases some specified different type of rammed earth construction technique is preferred here. So it achieves 50% reduction in carbon emission through the use of local material, locally sourced material, like around 80% of building material are from nearby areas, earth, stone and straw. Passive and sustainable design, it's an example for passive and sustainable design. It integrates passive solar design, rainwater harvesting and thermal mass wall. So the walls are thicker, as you can see from the windows itself here. So this is what is achieved here, and how the veranda and all that acts as a buffer space for, especially for the entrance, so that sunlight doesn't enter these living area, and you can see the depth of window. So with this the wall itself protects the entry of direct sunlight. So the tradition as well as modern innovation is possible in earth based construction also. So you may not have seen something like this building using a rammed earth wall. It is that typical building that comes to our mind when we say something a building with the design of rammed earth wall. So in terms of aesthetics and sustainability, it also promotes the aesthetics. It is not something which is designed with minimal consideration. So there are some specific design ideas that are being used here in the building. So to conclude this lecture, we can say that we understood on how contemporary innovations are transforming traditional earth construction into more durable and efficient as well as sustainable building method. We learned different mechanization techniques that improves speed, precision and quality in earth construction. We also explored structural advancement that enhances strength, stability and safety of earth construction. We also examined sustainability aspect of earth construction, including the use of local material and reduced environmental impact. We also analyzed the energy and carbon performance of earth buildings and their role in lowering embodied energy. Then we explored some case studies from Hunarshala Foundation, also one from Casa Eco Community Center and Modern Rammed Earth House in Spain, to understand how real world applications of sustainable earth architecture is possible. Overall, we will try to understand that combining traditional knowledge with modern technology is a solution for future ready, climate responsive and low cost construction. So these are activities which are suggested, which you can complete at the end of the lecture, and then post it in the discussion section. We will have discussion on the same. So in our next presentation, we will be discussing about advantages, limitation, performance issues and also some case studies related to success and failure of earth based construction. So these are resources which you can refer for more understanding on earth based construction. And with this, I would like to conclude my lecture and hope that you have learnt about earth based construction in detail and understood how these techniques, especially earth based techniques, promote sustainability by linking it with some specific SDG goals. So with this, I would like to thank you for your patience listening and hope to meet you again in the next lecture.